Hey, there she goes. Finally, we got her working. I don't know why it took so long, but we got her working. Yes. Sure. Okay. Buddy over here wants to do some trigonometry and he's having some troubles. Don't worry, bud. It just took me a while to get it running. I have issues with it every time, so we got it running. That's all that matters. Actually, funny story. All I did was make a box so that I could set my monitor on it and turn it into a standing desk, which is a nice thing because then I can switch between them really easily. Okay, so first off is just triangles. Now, you say you don't know really anything about these trigonometric ratios. Like, give me a little bit of a breakdown of what you do know and what you don't know. Based on, like, the reference sheet I sent. Okay. So, you know about reciprocals. So, the things that you are having a hard time understanding is actually using them? Like, applying them? Is that what it is? Like, these first three triangles, they were pretty easy? Like, I'm not sure what you're referring to as special triangles. Are you meaning just triangles that are not right triangles? Or are you referring to special triangles as in the important two that I sent you? So the important two that I sent you, they're actually just regular triangles, but the side lengths are important and the angles are important. Okay? They're ones that have simple answers, basically, when it comes to trig ratios. The angles are 45, 30, and 60 degrees. They have special, easy answers. And that's where that trigonomic functions of special angles, that little box, this has all those important ratios, and you'll use these all the time. And most often you'll see them on the unit circle. I just put it as a box on this reference sheet because it was quick and short and small. On the next page that I'll make a full unit circle and have that one on there as well. So let's take a look at your homework then. Like number 2 is just, but so that's the thing. There's nothing like to use it. It's just do the trig ratios. So for example, yeah. No, that's actually much simpler than you think. So our first triangle is this 45 degrees one, right? And then the second triangle is 30 degrees, but I'm gonna have to kind of not make it super accurate on the fly. 30 degrees, this is 60. This is root 3, this is 1, this is 2, and this is 1, 1, root 2. So question 2 is actually very, very simple once you know these triangles. So it says sine of 45 degrees. So you're going to have this whole question. And like times cosine of 45 degrees. I'm just going to do those 2 quick ones. I'm not going to bother with the plus one. You can do that afterward. So sine, the ratio of sine, which is again on the reference sheet, is y over r, right? Or otherwise known as opposite over hypotenuse. Okay? So look at your 45 degrees and look at your opposite, which is 1, and your hypotenuse is root 2. So sine of 45 degrees is 1 over root 2. You do the same thing again with the cosine. Cosine theta, by definition, is x over r, or adjacent over hypotenuse. So cosine 45 degrees is again 1 over root 2. Yep, they're all the same. Yep. Just use SOHCAHTOA like normal. That's how everybody remembers it. I actually just do it with this y and x and stuff. And then use the special triangle because the special triangle has the angle and the side length. So 3 is they're giving you a ratio. Okay. Well, so let's just finish this little thing here first. So sine 45 times cosine of 45 is, which we found out is 1 over root 2 times 1 over root 2. Root 2 squared is just 2, so that's just 1/2. Okay. So like that's how you do each of these little things here. You just use the special triangles, use your SOHCAHTOA to find those out. And it'd be easy and done. I'm not sure how like you would have been taught this. Like any differently. This is a pretty So this question here, this is what we were doing, right? The sine of 45 times cosine of 45. I don't know what to tell you, man. Okay. Sine 45, cosine 45, which we found out was 1 over root 2 with sine of 45. And cosine of 45 is 1 over root 2. So we just multiply these two together. So this is like when we multiply together, it's like this. So when you square a square root, this is just 1/2. And you do this same process with everything in question 2. Sine 30 degrees, cosine 60, 1 minus 10, 45, all those things. So in question 3, we are given a ratio. This says that cosine of theta, they use phi, cosine of phi is -7 over square root of 53. Okay? And phi is between 0 and 360. Okay? So the thing about the next piece is which quadrant does it lie in? And then justify your answer. So first we're going to take a look. Remember that cosine of theta is a x over r, right? Okay. Which means that we would have -7 is equal to x, and then r is equal to the square root of 53. Okay. One quick side note, an important one. R cannot be negative. R is a length. You can't have a negative length. Okay? You can have x being negative, you can have y being negative, you can have them both being negative, but R is always positive. Okay? Then the next thing to look at. Well, this doesn't quite give us enough information. We know that x is negative, but if we look at the 4 quadrants, there's nothing to use. We're still going to finish this out here. This is quadrant 1, this is quadrant 2, 3, and 4. We can think about this as being the y-axis and the x-axis. So let me know if you're good with this quadrant description. The quadrant is these portions. Okay? So quadrant 1 is like everything in this area. Quadrant 2 is everything in this area. 3 is everything in this area. And 4 is everything in this area. Okay? See what I mean? So quadrant 1 is everywhere that y is positive and x is positive. See that? Y is positive and x is positive. Quadrant 2 is everywhere that y is positive and x is negative. Quadrant 3, x is negative and y is negative. And quadrant 4, y is negative and x is positive. See those? The nice thing about drawing this is all I'm doing is just writing out what it is. Okay? This is so you know what an axis is. Like when you draw like a line or anything like that, right? A y-axis and an x-axis, and you have some equation that you draw a line. The same thing. Nothing's changed. Okay? Same idea. Here's the origin 0. Y is positive. X is positive. X is negative over here. Same idea. Negative y. Okay? It's the same thing. Nothing's changed. So all I did was just kind of like describe what's happening in each quadrant. Okay? Okay? So now we need to justify which quadrant we think it is. Here's our problem. We've got x is negative 7 and r is square root of 53. R is always positive. The only thing that we're kind of missing here is what's our y going to be? And the funny thing is, we need to justify which quadrant it's in. Well, this is x is equal to negative 7. So we know x is negative. So if x is negative, change our color up a bit. X is negative is all over here. These two quadrants, x is negative. You see that? It could also be quadrant 3, because x is negative in quadrant 3. Now, the question does not give enough information to narrow it down. Based on what it's giving us. So, if it said that phi was between 0 and 180 degrees, instead of 360, we'd be able to narrow it down to which quadrant. This problem itself actually has an error in it. Because there's an assumption that has to be made. We have x, we have r, but we need y. There is one last thing that you need to remember, and I'm sure you've had it drilled into your head a lot of times, called the Pythagorean Theorem. Do you remember the Pythagorean Theorem? Good. X squared plus y squared equals r squared. So we need to plug in our values and solve for y. You got it. So x squared is minus 7. Minus 7 squared. Y squared we don't know. R is the square root of 53. So square root of 53 squared. Solve for y. Y squared is equal to, well, the square root of 53 squared is just 53. And then 7 squared is 49, so we'll take 49 away from both sides. Y squared equals 53 minus 49, so y squared is. This is where we run into an issue, because when we square root, we get plus or minus. So y equals the plus or minus of 2. In your question, it doesn't state whether y is positive or negative. It gives us the entire interval of 0 to 360. So I guess we can assume y is positive. Yeah, just like the interval is, if they stated that the interval was between, well, you're supposed to be getting better, bud. Over time, you're getting better. So the other trig ratios, well, let's bump it up, man. Bump it up. Yeah, I don't know how you would change so drastically. What changed? The teacher? My nephew had something like that as well, where the teacher changing and his grade changed dramatically. That's cool. Anyways, we should keep moving. Okay, so we're gonna just assume y is positive because the interval includes both the positive and negative versions. Well, nope. Well, for A, yes. For A, it is just stating that we think it's in quadrant 2 or 3. For B part, you actually just need to list all the other trig ratios. But you have X, you have R, and you have Y, so you just fill them out, right? Mm-hmm. Yeah. So you already have cosine, but you need to fill out all six. You need sine, cosine, tan, cosecant, secant, and cotan. All six. That's what it says for B part. State the other five trig ratios. And C would be calculate the principal angle to the nearest degree. So that means you have to learn how to use your calculator. Do you know how to use your calculator? So when it comes to trig ratios and your calculator, well, you have to know how to use your calculator to be able to find the angle, unless you're literally just supposed to write cos inverse of some numbers. So, for example, we have cosine of phi is equal to negative 7 over square root of 53. Okay. Well, we need phi, and that is equal to the cosine inverse of negative 7 over square root of 53. Because you need to take the inverse of both sides to be able to give you what you need. And on your calculator, there is a special button. I could just bring it up and show you real quick. Right here, cosine for the inverse. So you just type in cosine inverse of negative 7 divided by the root of 53. And make sure your calculator is in degrees. So let's finish this one. So the interesting thing about this is that when you type this in for phi is 164 degrees. Okay. The interesting thing about this is that the phi angle here, this is 164 degrees. Okay. So this would technically be in quadrant 2. However, it doesn't tell us what the other ratios would be, so that's why it's an error. Because it doesn't tell us like the difference, because this phi of 164 degrees could also be like down here. Okay, that's why there's two different answers. But anyways, let's move on to 4. Is it? Next 3 weeks, you don't do anything in school? What do you mean the teacher doesn't teach? What is... Wait. Play practice? Yes. Okay. Neat. I'm not even gonna go into it. Not even gonna go into it. Okay. 4. The maximum grade slope allowed for highways in Ontario is 12%. Predict the angle theta to the nearest degree associated with this slope. The only thing that I would have question about is, what does it mean? Because to me, when I read this question, I mean, it tells you the angle. So this is supposed to be, the slope is 12%. Okay. We need to predict what this angle could be. And then we need to calculate it. So would be a good way to do this. Just with the fact that it's 12%. Slope is rise over run. I'm just gonna do it the regular way. So if rise over run is 12%, that means that this would be like y over x. Here's our theta. So this would be tan of theta is equal to y over x, which is equal to 12%. That's what I would do. So with that, we need to just kind of predict an angle instead of calculate it. I just calculate. Tan inverse of 0.12. Get 6.84 degrees. So nearest degree would be 7. And then determine the 6 trig ratios. You have, what I would write here is simplify it. So y over x is 12%. 12% is the same as writing 12 over 100, and then simplify. Tan inverse. And 12% is, I don't ever like using percentile as a number. I always use decimal because people always will screw up percentages. So if you think of percentage as a decimal number, it works out better. Okay. 12 over 100 simplifies. 6 over 50. Well, that can simplify again to what? 3 over 25? No, I just calculated it. If I were to guess, I would have guessed something like, I don't know, 10 degrees. This is the actual calculated. A guess would be like, I don't know, degrees. Tan inverse. This is how you calculate it. Because tan theta is y over x, which we took to be 12%. So tan inverse of 12%. And then you just needed the values for your trig ratios. Well, y over x is 12%. So 12% is the same as 12 over 100. And then simplify. So y equals 3. X equals 25. You need r, so use Pythagorean Theorem. Solve for r. And then do your other ratios. It's literally just this reference sheet. 9 of theta is y over r. So whatever your r is, so this is 9 plus 25 squared is what? 9 plus 25 squared, 634. 100. Wait, what did I say? 9 squared. See what you can simplify out of that, but that's what you do. That's all it is. Okay, question 5. This one's actually a lot simpler. it gave you an incline, and it gave you a run, 7.11 meters, and it's asking to see what the length of the ramp is. So it's asking you to find R. Just use the trig ratio to find R. Remember that, what is it? Cosine of theta is x over r. So then you rearrange. You'll get it, but just follow the reference sheet. It's much simpler than you think. Okay. Question 5. Remember that cosine of theta is x over r, so we just rearrange this. So r times cos theta divided by x. So x over cosine of theta. Six. Given the angle is between 0 and 360, determine two possible values of theta where each ratio could be true. Fetch the principal angles. This is a kind of an awkward set of questions. To me, anyways. Decimal numbers. Ugh. So in 6, we have 0 is less than theta, which is less than 360. And we need to just do, take a look at the ratio. This first one is cosine of theta is equal to 0.6951. Meaning that the ratio of the side lengths is less than 1. And it's positive. Okay? Let's take a look. I don't use decimals very often, so I have to double check. Let's see. Okay, we have to have some ratio, some angle, but the ratio for cosine, which is x over r, is 0.6951. So here's theta. Where is it possible that cosine of theta could be 0.6951. This is the angle. Right? This is an angle. This is a triangle. Here's like our zero, our origin point. So we always go from our origin point up to our arm. Are you having trouble with why I drew this? Because remember that all these angles, all this stuff is triangles. And then on the axes. Remember, this is like a y-axis and an x-axis. Okay. So the ratio is 0.6951. It would help you to draw it because it's visual and understanding. It just by the idea of knowing that the ratio is positive tells you a lot about where this could lie. So cosine here was positive. So that means you know that x has to be positive, which means it's either in this quadrant, quadrant 1, or it's in quadrant 4. If the ratio was negative for cosine, then we'd know it would be in this quadrant. Or this quadrant. Right? If negative. See that why that helps? And it's asking you to sketch the angles anyways, so you need to draw this anyways. Stop thinking things are confusing. Not about confusing, just about what is it. Remember, the ratios and the triangle. Okay? In your coordinate axes, like we've gone through before, here's your y, here's your x. This is a positive x-axis. This is positive y. You know what I mean? Like, this is all the same. Okay? Negative x. Negative y-axis. Okay? Just always come back to the idea that you're just putting a triangle on an axis. An angle on an axis. And your positive x-axis is your 0. So wherever it goes from that, this is what you're drawing. There is no other thing. You are drawing a set of axes. You are going to determine, because it says there, sketch both principal angles. Remember, y and x. You're going to draw your principal angle, and there's your theta. As a side, you know that this is like the y is your height, x is your distance, r is your hypotenuse. Okay? Good. So, yeah, I'm not going to make it go anywhere. We need to draw each one. So, for this example, we know that cosine of theta is a positive ratio. Okay? Remember that cosine of theta is x over r. Okay? Again, from using our ratios on our reference sheet. X is positive because r is always positive, which means it's going to be in quadrant 1 or it's going to be in quadrant 4 because that's the only two places where x is positive. See, the positive x-axis. Okay? Yes, the positive quadrants. Since x is positive, we keep it in x as the positive quadrant. So x is positive from this area, right? Meaning the angle is going to be like in this quadrant, quadrant 1, and it's if we have another one, it's going to be in this quadrant, quadrant 4. Because we have two possibilities. Okay? We have two possibilities. Again, the x-axis is positive everywhere to the right, okay? Everywhere to the right is positive. Okay? Which means it can be either in quadrant 1 or it can be in quadrant 4 because that's two places where x is positive. Okay? Good. So now just use your calculator and find out what the angle is. So cosine inverse of 0.6951 is what? Okay. Now that we've found what the angle is, okay, type it in, make sure you get what I got. I'll make sure that my screen is still visible. $45 point what? Good. So let's just round up to 46 degrees. Okay. It says, what's another possible angle? Well, like I said, the other possible angle is the one that's below the y, below the x-axis, where y is negative. So what is this angle? Well, this angle is negative theta. So that would be like negative 46 degrees. Okay. Going down is a negative angle. Going up is a positive angle. Does that make sense? Well, I haven't finished this yet. Yes, because x, one where both x and y are positive, and one where x is positive and y is negative. Yes, there is two possibilities, and it asks us for both possibilities. You got it. You're doing fine. Now the only thing is we have to finish this one. Okay. Remember that this is 0 and this is 360 degrees. Okay. One full circle. Draw a quick one. One full circle is 360 degrees. Okay. We need the angle of this line. We need this whole blue angle to be able to finish off our question, which we found out already that this is 46 degrees in here. It's okay. We're almost done, bud. Just we just gotta keep on pushing through. So, are you good with these two small diagrams? Perfect. Okay. We need the full blue angle, but we have 46 degrees here. So the second angle that we need is the full 360 minus the 46. That's your two angles. Theta can be 46 degrees, or theta can be 314 degrees. So you see how we went through that problem? I'm just going to do the reasoning on B with you real quick. And then I think that should be all we need. Okay, the reasoning on B. No, 7 you can do. I've already given you all these reasoning. Yep. Question with B. So what's your question with B? We know that tan is negative. Start with that idea. We know that tan is negative. Okay. What is the ratio of tan? Look at your reference sheet. What is the ratio of tan? Don't say x and y. What is the ratio? No, like as using y and x, write down the ratio. Y over x. Like you just write down the ratios as you see them. Okay? Now we know that tan theta is y and x. Okay? But we also know that tan theta is negative. A number is negative. So for example, we have these two numbers. We have y and x. A number is negative when either y is negative and x is positive, or y is positive and x is negative. See what I mean? If they were both negative, a negative times a negative is positive. If they're both positive, then it doesn't work. So if they're both positive, it doesn't work. If they're both negative, it doesn't work. So our angle has to lie in quadrant 2 or in quadrant 4. Do you see that reasoning? We'll just do the same thing that we did before. Take the tan inverse. So, like, as always, you're looking for theta. Theta tan inverse of negative 0.7571. This will give you tan inverse of negative 0.7571 is going to give you negative 37 degrees. So, remember what it's telling you. This is negative 37 degrees. Okay? Negative 37 degrees is this way. Okay? Which means, again, if we draw our little axes, we need this angle because it's going to be between 0 and 360. This angle is 360 minus 37. 323. Well, look at the reasoning with 7. Start with what is the reasoning for 7. You have, they say they found 3 possible angles. And cosine, so we have cosine of theta is equal to 4 over 5. Again, where is cosine positive? Where is cosine positive? Cosine is the x-axis. 1 and 4. So it can be in here or here. And here's the x-axis. It's positive. You can't have 3 angles for one ratio. The only way you could do that is if the domain, the 0 to 360, isn't 360. If it was like 540, then you could continue and have another angle. But because it's only from 0 to 360, then it only has 2 possibilities. If it went from 0 to 720, so all the way to around, well, then there's 4 possibilities. You know what I mean? We don't need to. We don't need to find it. We just need to explain why he can't have 3 angles. Only answer the question. You don't need to do more work than what's the question asking. Yeah, if you wanted the 2 angles, it's the same as the question 6. You're just taking the inverse, and there you go. You're thinking too much. Hold up. You're thinking too much about just trying to memorize a formula rather than understanding what it is. Remember, this whole thing, one full loop, is 360 degrees. Okay? One full loop is 360 degrees. If we need an angle that's here, and we know this one, remember that all the way around is 360. But we only need from here to here. So phi is what we need. It's less than 360 by theta, so 360 minus theta. Do you see what I mean? It's not about trying to memorize, it's about just understanding what it is. Okay? Just a different angle. Phi, yes. I'm not sure. Like, give me a reference. I don't know what you mean because that word doesn't actually exist. Tangents? Are you referring to like figuring out quadrants? The quadrants. Okay, so they are labeled 1, 2, 3, and 4. Okay. Okay, they are just labeled 1, 2, 3, and 4. And they're just the area between the different axes. Okay, so this is like your y-axis and this is your x-axis. Just like any other set of axes you have before. Okay? Be good so far. Determining whether it's positive or negative is literally just by looking at it just as a regular set of axes. For example, x is positive to the right of the origin. Okay? Y is positive up from the origin. You see? X is negative. And then y is negative. Just like your regular set of axes. What do you mean? That's all there is. So like if I said cosine of theta is negative 1 over 2, like this is what you're asking, I'm assuming. If you have some angle, some trig function, tan or cosine or sine or cosecant or cosecant, you remember, you just break it down into the ratio. The cosine is x over r. So r can't be negative, so x is negative 1. R is 2. X is negative, so that means it's somewhere over here. Or over here. That's it. Like, that's all there really is to these. If this question had saying that the angle theta is between 180 degrees and 360, that would tell us where the y is now. Because since I put this 180 to 360, that means that it's only in the bottom half, so that means it has to be in quadrant 3. See what I mean? If they said it was between 0 and 180, that means it would be in the top half. So depending on what the domain is how you find the other one as well. Okay? Okay. I need to help one other person before I have to go. So this will be it for now. Okay, bud? Thanks, bud. Yeah, I'm gonna send you the pages. Thanks for the $5. The sound actually came through this time. Hmm. Yeah, I'll send you the pages. I'll do that now before I'm... What is the date today? 5. Okay. Jeff, let's see what you wanted to ask. Your goodness? What's your goodness? Well, you are a bit overzealous, so I could say a fair amount. Okay, let's see these. Let's see these questions you wanted to go through. You will type because you forget how to do them. Okay. You don't want to just send me a picture on Discord? So minus 9 to the power of 3 over 2. Well, to be fair, if you just send me a picture, then I know for sure what it is you're trying to say. Because there can be a loss of translation at the time. I mean, the camera is black on. Just take a picture and send it to me. Like you would just take a regular picture with your phone. And then just send me the picture. Minus 9 to the 3 over 2. Okay. I'm assuming we're allowed imaginary numbers. Remember that this is the same as like... Okay, if we don't have parentheses, minus 9 to the 3 over 2. If we don't have parentheses, then it would just be the same as minus 9 to the 3 over 2. Okay. So what's the square root of 9? We can write this as the square root of 9 cubed. Yeah, just negative 27. Okay, so we've got negative 125. And it's in parentheses this time. So the negative 1 over 3. Okay. Remember, a negative exponent just means 1 over the positive exponent. So this is 1 over negative 125 to the 1/3. Which, remember, is just 1 over the cubed root of negative 125. So what is that? Yeah, negative 1 over 5. Hey, you got this, man. Easy. Just a little refresher. Yeah, just send me a picture. Hey, you send me a picture. I'm going to be right back. I'm going to check on my timing. Okay, I have 10 minutes. Let's see what you got. And then I'll have to be back later. So, let's take a look. Okay, I need to send you some reference pages. Steph, are you up on your Discord? I need to go pick up a bunch of wood from a felled tree, so I'll be back later. I'm going to send you a couple of reference pages. I just sent you them on Discord. But these type things are all the same. Okay? So if you have a number like so in the first page I sent you with the exponent laws, you can actually just follow these kinds of exponent laws to kind of simplify and figure things out. So for like 15, you had 5 to the 1/3 to the power of -3. Okay? Well, if you look at the exponent laws, this is the same as like x to the a to the power of b. So that's just x to the a times b. Okay? So 5 to the 1/3 times -3 is 5 to the -1 because the 3 cancel out. Okay? Let's see. What else do you have here? 19. 9 to the 1/2 plus 16 to the 1/2 squared. This should be pretty easy for you. Because remember, this is just like saying the square root of 9 plus the square root of 16. So what's the square root of 9? Okay. So 3 plus 4 squared is 7 squared, which equals 49. Okay, let's see, what was the next ones you wanted to look? So these other ones with separate exponents, you can just do for these ones, it's the same idea. Like 22 is the cubed root of e to the power of 4 and q. Remember that you're just going to write this as e to the power of 4q to the 1/3. And then this one is of that form in our reference sheet. So I'm not sure which ones you want to go through then. Which ones do you want to go through? 25. I can't really see 25. I'm gonna just take a guess. You let me know. Square root of a squared b. I think the whole thing is to the power of 5? Negative 2? No, 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 child. Don't even have a girlfriend. Well, I'll get one when you help me get rich, okay? We'll get this so we have 100,000 people watching, and then we'll talk about girlfriend. Okay. I'm assuming this is what 25 looks like. It's hard because it's kind of half cut out. Okay. Again, we just have to remember writing that this square root is the same as the 1/2. So, we've got a to the negative 2b to the power of 1/2, and that's to the power of 5. So, using like this top one again, x to the ab equals x to the ab, this would just be a to the minus 2b to the 5 over 2. Now distribute into each one. So we've got a to the minus 2 times 5 over 2 and b to the 5 over 2. So 2's cancel out, so we've got a to the negative 5 and b to the 5 over 2. See how that works? So those pages I sent you is exactly what we're doing. We're just doing little variations of these, just little references. Okay, last one and then I'll have to go. So 27. 4th root 16, what is that, cubed? Times a to the minus 2 over b to the power of 6. So remember, 4th root is the same as 1 over 4 as an exponent. So we're just going to write this whole thing to the power of 1 over 4. So 16 cubed times a to the negative 2 over b to the 6th, all to the power of 1 over 4. Just distribute into each one. They are multiplied, so it can be distributed. If there was an addition sign or subtraction sign, then it does not work the same way. You just have to be careful of that. So 16 to the 3 over 4 times a to the minus 2 over 4 over b to the 6 over 4 and simplify. $16. Let's see. What do they want it as? The fourth root of 16. I'll do it this way. Fourth root of 16 cubed. Then times a to the negative 1/2 is 2 over 4. B is 6 over 4. 6 over 4 reduces to 3 over 2. And so I'll just write it on the bottom, b to the 3 over 2. Since they want it just in negative exponents all on the top, this will just reduce to 8, a to the negative 1/2, and then b to the negative 3 over 2. Do you see each step and what happens there? Yeah, it is pretty simple once you get the handle of it. Yeah, you won't make any mistakes. By knowing you, you'll be fine. Just a little refresher and you're good. Yeah, I'll talk to you later. Okay. I'm going to turn off and I will go haul some wood. I'll be back, like, textable in a while. I'll talk to you later.